Did you know that smart charging and discharging strategies are essential to maximize the performance of energy storage systems? These strategies not only increase revenue, but also optimize grid operation and stability. In this video, we'll explore 3 key strategies: energy arbitrage, solar management, and participation in ancillary markets. Join me to discover how these techniques can transform your projects. Energy arbitrage is an advanced technique used to optimize cost-effectiveness in energy storage systems, such as large-scale energy storage batteries, BESS. What is energy arbitrage? Energy arbitrage involves charging the storage system, BESS, when electricity prices in the market are low, and discharging it when prices are high, typically during peaks of high demand. This approach takes advantage of fluctuations in the electricity market, maximizing revenues by selling power at the most profitable times and reducing operating costs. The key requirements for implementing energy arbitrage are: spot market analysis. It is essential to have a system in place to monitor and predict electricity market prices. Advanced predictive analytics tools and artificial intelligence models are essential to identify the optimal times to load and unload stored energy. Rapid response capability. To maximize profits, the system must be able to react in real time to changing market conditions. This requires technology that can adjust loading and unloading operations instantaneously, minimizing delays and maximizing opportunities. A case study in Spain demonstrates the potential of this strategy. A BESS facility implemented an efficient energy arbitrage system, achieving a 20% increase in revenue by focusing its load shedding on peak demand hours. This success is attributed to the use of advanced price forecasting tools and an agile system that allowed a quick response to market fluctuations. This strategy not only offers an economic advantage, but also contributes to stabilizing the power grid by mitigating the effects of peak demand and encouraging the efficient use of energy resources. Efficient solar energy management is key to optimizing the generation and use of photovoltaic resources, especially when complemented with storage systems such as battery energy storage systems, BESS. The main objective of this strategy is to maximize the integration of solar energy by storing the surplus generated during peak solar irradiance hours and releasing it at times of low generation. This ensures a more efficient use of the energy produced, reducing dependence on external sources and minimizing energy waste. The key benefits are reduced losses due to energy dumping. In many occasions, saturated power grids cannot absorb all the energy generated by solar plants, resulting in the dumping of surpluses. With an efficient storage system, these surpluses are stored for later use, avoiding significant losses, maximizing self-consumption. This strategy is particularly advantageous for industrial plants, where efficient use of solar energy can significantly reduce operating costs by reducing dependence on the grid during peak demand hours. The key requirements for its implementation are dynamic monitoring of solar production. An efficient management system must be able to automatically adjust the charging and discharging of the BESS based on real-time solar irradiance. This requires advanced monitoring and control tools, integrated with advanced analytics technologies and predictive algorithms. Agile responsiveness. Since weather conditions and solar irradiance can vary rapidly, the system must be flexible enough to adapt to these changes without significant interruptions. An outstanding case in Portugal shows how a solar plant was able to reduce energy waste by 30% by implementing an efficient solar energy management strategy. By using an advanced BESS system and dynamic irradiance monitoring, the plant optimized energy storage and use, maximizing self-consumption and minimizing losses. This strategy not only brings economic benefits by reducing operating costs, but also promotes sustainability by optimizing the use of clean, renewable energy. Participation in ancillary services markets is a key strategy to optimize the profitability of energy storage systems, BESS, while supporting grid stability and reliability. Through this strategy, BESS is used to provide essential services to the power grid, such as frequency regulation, maintaining the balance between generation and demand, capacity reserve, guarantee energy availability at critical moments, rapid response, react immediately to unexpected events in the grid. By participating in these markets, the facilities not only earn additional income, but also actively contribute to the stability of the electricity system. The key requirements are immediate responsiveness. Efficiency in ancillary services markets depends on the ability of the BESS to react within milliseconds to signals sent by the network operator. This requires advanced control systems and high-speed storage technology. Contracts with grid operators. It is essential to establish agreements with the relevant electricity operators, such as Red Eléctrica de España, in Spain, or ERSE, Entidade Reguladora dos Serviços Energéticos, in Portugal, in order to formally participate in the ancillary services markets. These contracts define the terms of participation, remuneration, and responsibilities. A case study in the Iberian market highlights how a hybrid plant was able to generate stable revenues by providing frequency regulation services to the grid. The combination of renewable generation and efficient storage allowed this plant not only to meet technical requirements, but also to take full advantage of opportunities in the ancillary services market. This strategy not only ensures an additional source of revenue, but also positions the facility as a key player in the transition to more resilient and sustainable power systems. To summarize, energy arbitrage maximizes revenue by taking advantage of market fluctuations. Solar management reduces losses and improves operational efficiency. Participation in ancillary services stabilizes the grid and generates additional revenue. ASA recommendation: implement an advanced energy management system, EMS, to maximize the performance of these strategies. If you want to implement these techniques in your projects or need customized training, contact me on LinkedIn. Let's take your BESS to the next level. And don't forget to subscribe to the channel for more content and keep learning about BESS systems.